In this lesson, we're going to solve linear systems by elimination. We've already learned the method of substitution, so another method of solving a linear system of equations is elimination. Now, the process for doing that is, first of all, to line the equations up. So for example, we might put the x terms first, the y terms second, the equal sign next, and then the constant term. We're then going to determine which variable we want to eliminate. We're going to multiply both equations by the correct quantity so that the coefficient of each relevant term is the same. So, for example, if we want to eliminate the y terms, we'll make sure that the coefficient of each y term is the same. Then we have to take note of the sign, either positive or negative, of the terms we're looking to eliminate. If these terms have the same sign, in other words they're both positive or they're both negative, then we could subtract one equation from the other. But if the signs are different, then we can add the equations. What we're then going to do is solve for the remaining variable, and then substitute the value from this step here into one of the original equations to solve for the other variable. And finally, at the end, we're going to write a good therefore statement. So let's see what that means by putting it into practice. What we want to do here is solve each of these systems of equations that we're about to see by the method of elimination. Now in this first question, we see we've got 2x plus 5y minus 18 equals 0 and 3x plus 7y minus 25 equals 0. Well, the first thing we want to do is line them up, and we see that they're actually lined up well. We've got our x terms, and then our y terms, and then our constant terms, our equal sign, and then our zeros. So we're good to go there. Now we look at the coefficients. We have a 2x and a 3x, and I could multiply this 2 by 3 and multiply this 3 by 2, and they'd both be 6. I see I've got a 5y and a 7y. Well, I could multiply this 5y by 7 and this 7y by 5, and they'd be the same. Sounds a little easier to deal with the x's. We're going to multiply this 2 by 3 and this 3 by 2, and they're going to be the same. However, whatever we do to one term in an equation, we have to do to every term in that equation on both sides of the equal sign. So if I'm going to focus on equation 1 and multiply this x term by 3, I better multiply this term by 3, this term by 3, and the 0 by 3. And then if I'm going to multiply this 3x by 2, I better multiply the 7y by 2, and the 25 by 2, and the 0 by 2. So that's what I'm going to do. I'm going to multiply the entire first equation, every term in it, by 3. So 2x becomes 6x, positive 5y becomes positive 15y, negative 18 becomes negative 54, and 0 times 3 is 0. So I get 6x plus 15y minus 54 equals 0. And then look at the second equation, and I want to multiply every term by 2. So I get 6x plus 14y minus 50 equals 0. 6x plus 14y minus 50 equals 0. Okay? So now I've got an equation on top of an equation. And I see that since the signs, I have the coefficients of x the same, and the signs are the same. See, without looking at the red bracket, the signs are the same. I've got positive 6x and positive 6x. Well, when the signs are the same, that tells me I want to subtract in order to eliminate. So I'm going to put a big minus sign and a big red bracket around the whole thing. What that does is it tells me 6x minus 6x is 0. 15y minus positive 14y is y. Negative 54 minus negative 50 is negative 4. Equals 0 minus 0 is 0. So what I have is y minus 4 equaling 0. Now what I can do is simply solve for y. Y is 4. I'm then going to substitute that value into either of the original equations. So I could have chosen equation 1 or equation 2. I chose equation 1. I have 2x plus 5y minus 18 equaling 0. Now I'm going to substitute in for y the value of 4. I have 2x plus 5 times 4 minus 18 equals 0, which means 2x plus 20 minus 18 equals 0, which means 2x is negative 20 plus 18, or in other words, 2x is negative 2. This means x is negative 1. So I've got y equaling 4 and x equaling negative 1, and I can therefore say that the solution to the system is negative 1, 4, x coordinate, y coordinate. Let's go to our second one. Our second one is 5x minus 4y plus 32 equals 0, and 9x plus 3y equals negative 78. The first thing I want to do is line them up. See, I have my x's and my y's, but I have a constant term, then an equal sign, and here I have an equal sign, then the constant term. So let's subtract 32 from both sides of equation 1. And what we end up with is 5x minus 4y equaling negative 32, and 9x plus 3y equaling negative 78. Now, without paying attention to what I've written here in red, just look at the fact that I realize I can eliminate my y's if I multiply this whole equation by 3 and this whole equation by 4. So multiplying every one of these terms by 3, 5x becomes 15x, negative 4y becomes negative 12y, and negative 32 becomes negative 96. Multiplying this whole every term in this whole equation by 4 makes 9x become 36x, 3y becomes 12y, and negative 78 becomes negative 312. And now what I've got is my two equations with y coordinates the same. But notice that the signs are different. So that means what I want to do is I want to add the two equations. I'm going to get 15x plus 36x equaling 51x. Negative 12y plus positive 12y eliminates it. Negative 96 plus negative 312 is negative 408. So I have 51x equaling negative 408. That means x is negative 408 over 51, which means x is negative 8. I'm now going to substitute that value into either original equation. So I could have chosen equation 1 or equation 2. I chose equation 1. 5x minus 4y plus 32 equals 0. Substituting in a value of negative 8 for x, I get 5 times negative 8 minus negative 4y plus 32 equals 0. Negative 40 minus 4y plus 32 equals 0. I keep my y term on the left and I add 40 and subtract 32 to get negative 4y equals 8 and y equaling negative 2. So my x coordinate is negative 8, my y coordinate is negative 2, and I can say the solution to the system is negative 8, negative 2. This next question is much the same. We just have to make sure we distribute the 2 into this bracket and the 11 into this bracket. So focusing on equation 1, distributing in the 2, we get 2x minus 6 plus 3y plus 4 equals 0. We're going to have our x and y terms on the left and our constant term on the right. And so we get 2x plus 3y equaling 2. Now equation 2, after we distribute in the 11, we get 6x plus 11y plus 11 equals 29. Keeping our x and y terms on the left, we get 6x plus 11y equals 29 minus 11, so 6x plus 11y equals 18. And we have our two equations, and they're lined up. X terms, y terms, equal signs, constant terms. So we put one on top of the other, and we realize if we were to multiply this 2 by 3, it would become a 6, and we could eliminate. So that's what we're going to do. Now again, don't pay attention to what's written in red yet, but what we do is we multiply every term in equation 1 by 3. 2x times 3 is 6x, 3y times 3 is 9y, 2 times 3 is 6. We leave equation 2 the same. And we see we've got x terms that are the same, and we can subtract to eliminate. So, but we have to subtract the entire equation. So 6x minus 6x is 0, eliminated. 9y minus 11y is negative 2y, and 6 minus 18 is negative 12. Well, if negative 2y is negative 12, then that means y is 6. So now I can substitute that into either of my equations up here. So I choose the first one. Substituting in a y value of 6, I get 2x plus 3 times 6 equals 2, or in other words 2x plus 18 equals 2. So 2x is 2 minus 18, which is like saying 2x is negative 16, or in other words x is negative 8. So the solution to the system has an x value of negative 8 and a y value of 6. The solution to the system is negative 8, 6.